Welcome, ladies and gentlemen, to the 30th lecture of this series of this course. In the previous lecture, we had discussed the simple random sampling. In this lecture, we are going to cover complex random sampling techniques. Complex random sampling designs are the mixture of probability and norm in the sense that elements of characteristics of both the designs, that is mixture of the non-probability design, sample designs and the probability designs is available here. We will in due course of this lecture, we are going to find that it is a kind of infusion of both the, and this is why such designs are called as mixed sampling designs, because many such designs represent a combination of probability and non-probability sampling procedures in selecting a sample. Therefore, the statisticians, they have developed this kind of sampling which is called complex random sampling for the practicality of the researchers, because as we observed that simple random sampling is though ideal, in many cases it is not very practical. However, if the randomness is not to be lost totally, and why we find that the complex random samplings methods or techniques have been developed which carry the elements of the simple random sampling also and the non-random sampling also, and by a fusion of, by a combination of these elements of these two types of sampling, the complex random sampling designs are developed. So, in this lecture, we are going to discuss some of these popular complex random samplings which are as follows. The first such sampling method or technique is the systematic sampling. In systematic sampling, in some instances, the most practical way of sampling is to select every ith item on a list, and the first item is selected randomly, and then every ith item is selected automatically, and that way the sample is prepared for the study. So, what we find here, that the element of or the characteristics of the random sampling has been introduced in the selection of the first item, whereas the other items have been chosen automatically. So, here this is a combination of these two, and this type of sampling is known as systematic sampling. Let us discuss it with an example. For instance, if a 4% sample is desired, 1 out of every 25, so what will be done? The first item has to be selected randomly from the first 25 items, or from the first 25 members. Go on adding 25 to all the items, they will be automatically included in the sample. So, if here say the 15th item is selected randomly, then go on adding 25, then the next item would be 40, then next would be 65, then next would be 90, then next would be 115, and this way go on till the sample is complete. During household surveys, this systematic sampling is best. Suppose we have to make a sample of 100 from 1000 household. It means that there is one selection of member or item household in the sample out of each 10. So, a household is selected randomly between 1 to 10. It is 6th house. Now go on adding 10, 16, 26, 36, 46, 56, 66, 76, 86, 96. This way, go on selecting the household and our sample is ready through the systematic sampling technique. Operating or selecting a sample on the systematic sampling basis. Then the next kind of sampling is the stratified sampling. If a population from which a sample is to be drawn does not constitute a homogeneous group, a stratified sampling technique is generally applied in order to obtain a representative sample. This stratified sample is a very popular method of sampling technique. However, this is applied when the groups are not homogeneous in the population. They are heterogeneous, and especially to give representation to their heterogeneity, the stratified sampling has been designed. Under the stratified sampling, the population is divided into several subpopulations that are individually more homogeneous than the total population. The different subpopulations are called strata, and then select items from each stratum to constitute a sample. As suppose here again project to study the level of satisfaction teaching in a university. The university has large number of faculties, and the nature of these faculties are quite different. The nature of medical faculty is quite different from the law, and the nature of law faculty is quite different from the commerce, and the nature of commerce faculty is quite different from the faculty of arts, we find that the population here is not homogeneous, is heterogeneous, spread into hundreds of subjects. So, it is better to go for a stratified sampling. And what is that? Make subpopulations which are strata. The subpopulation, the faculties of the university, or could be the departments of the universities, or could be the courses of the universities. So, we can have this substrata either based on the faculty or based on the department or based on the course that is run by the university. So, this strata or subpopulations are first to be made, and then the researcher has to select members or items from each stratum to constitute a sample. Since each stratum is more homogeneous than the total population, we are able to get more precise estimates for each stratum, and by estimating more accurately each of the component parts, we get a better estimate of the whole. I think we have been able to understand the concept of the stratified sampling, that to get the heterogeneous character of the population into the sample, we in fact adopt the stratified method of the sampling. We distribute the whole population into subpopulations based on their heterogeneity. So, what happens? That as much we make these subgroups, subpopulations, these strata become more homogeneous among themselves. So, the items are selected from each stratum to constitute a sample. Seen what is this? What is the stratified sampling? However, there are certain questions very highly relevant in the context of stratified sampling. That is, number one, how to form the strata. Number two, how should items be selected from each stratum? How many items be selected from each stratum, and how to allocate the sample size of each stratum? These are the questions which are to be clearly defined and which should be clear in the minds of the researcher. How to form the strata? The strata would be formed on some basis of characteristics. It's not without basis. As we discussed that, we reduce the population of the university or into subgroups depending upon the faculty, depending on the medicine, and depending on the courses that they will follow. There should be a convincing logic for the developing of the strata, subpopulations. It should not be done on whimsical basis. It has to be done on some logical basis. That is how to form the strata. If it is based on that, then we will find that the subgroups or the strata have in fact different kind of characteristics. Then how the items to be selected from each item. The best thing is of course simple random sampling, because the complex random sampling is a method which combines both non-random and random sampling. So, it is better that the items which are selected from each stratum to make a sample, they are chosen on the basis of the random or basis of the chance. Then how many atoms to be selected from each stratum, or how to allocate the sample size of each stratum. So, the best way is that all the stratum are given representation based upon their strength in the population. So, if a faculty is large, it will get greater number of students in the sample. If a department is large, then it would get larger number of students in the sample. And if a faculty is small, then it would get a small representation in the sample. And if a department is small, then it is going to have a small representation in the and that way, once we have selected and selected the required samples from each of the stratum, now collect them together, they become the sample of the whole population, which has been developed on the basis of the stratified sampling. The next that we are going to discuss is the cluster sampling. If the total area of interest happens to be a big one, a convenient way in which a sample can be taken is to divide the area into number of smaller non-overlapping areas, and then to randomly select a number of these smaller areas, usually called clusters, with ultimate sample consisting of all or samples all units in these small areas or clusters. Population is very large, universe is very large. So what we do? We make clusters, small groups, and then randomly select a number of these areas, and all the members who are in the clusters, they become altogether member of the sample when they are added together. When all these selected clusters are added together, they become member of the sample. Thus, in cluster sampling, the total population is divided into a number of relatively small subdivisions, which are themselves clusters of still smaller units, and then some of these clusters are randomly selected for inclusion in the overall sample. Then the next is the area sampling. What is that? If this cluster happens to be some geographical subdivisions, in that case, the cluster sampling is better known as area sampling. In other words, cluster designs where the primary sampling unit represents a cluster of units based on geographic area are distinguished as area sampling. The plus minus points of cluster sampling are also applicable to the area sampling. So, I shall be giving a quick example for this. Suppose we are working on the performance of the commercial banks in India, then it is a very large sample. We can do to make small clusters of say tehsils or districts, and then here the cluster is a geographical area, a subdivision, a tehsil or a district, and then we randomly choose these clusters or these geographical areas. So, the process is same as in the cluster sampling. The only difference that here the clusters are geographical units of either tehsil or subdivision or blocks or districts, and of course all the members of the area sampling, which is cluster, they are included in the sample, and when we add or total, when we add all these clusters which have been selected randomly, then they become a sample of the area, sample of the population based on the concept of area sampling. Then we have the multi-stage sampling. It is the further development of cluster sampling. Suppose again we want to investigate the working efficiency of the nationalized banks in India, and we want to take a sample of few banks for this purpose. The first stage is to select large primary sampling unit such as states in the country, which states to be included in the sample. Then we also cannot, suppose we have selected 2-3 states, we cannot include every of them, all of them. So, we select certain districts and interview all the banks in the chosen districts. This represents a 2-stage sampling design with the ultimate sampling units being clusters of districts. It is more than 2-stage, then it is multi-stage sampling, 2-stage, 3-stage, 4-stage sampling, that is to make clusters on the multiple basis, collecting states first, then collecting, then in fact selecting the districts, then selecting the say the cities in the districts. So, we have selected the sampling in 3 stages, and the last that is the cluster, is the city of the district. So, this is multi-stage sampling, where the sampling is done in various stages. Then we have the sampling with probability proportional to size. In case the cluster sampling units do not have the same number or approximately the same number of elements, it is considered appropriate to use a random selection process where the probability of each cluster being included in the sample is proportional to the size of the cluster. For this purpose, what we do? We list the number of elements in each cluster irrespective of the method of ordering of the cluster, and then we apply the sample systematically the appropriate number of elements from the cumulative totals. That is the sampling with probability proportional to size, where the in case they have not, the clusters does not have same number, or it is considered appropriate to use a random selection process where the probability of each cluster being included in the sample is proportional to the size of the cluster. So, that is the sampling with probability proportional to size. Then we have the sequential sampling. What is that? The sample design is somewhat complex. The ultimate size of the sample under this technique is not fixed in advance, but is determined according to the mathematical decision rules on the basis of information yielded as survey progresses. This is usually adopted in the case of an accepted sampling plan in the context of statistical quality control. There are activists in a particular group because of which they do not present the viewpoints of other groups. When a particular lot is to be accepted or rejected on the basis of a single sample, it is known as single sampling. When the decision to be taken on the basis of two samples, it is known as double sampling. And in case the decision rests on the basis of more than two samples, but the number of samples are certain and decided in advance, the sampling is known as the multiple sampling. But when the number of samples are more than two, it is neither certain nor decided in advance. This type of system is often referred to as sequential sampling. Thus, in brief, we can observe or conclude that in sequential sampling, one can go on taking samples one after another as long as one desires to do so. Then these were some of the important complex random sampling designs. In fact, these designs are very popular, especially the systematic sample design, the stratified sampling design, and the cluster sampling designs. These are very popular for the researchers because they provide them a kind of freedom also and a kind of strictness also. These are both gathered here, and this is why this is called the cluster sampling, in which both the element of the random sampling and the non-random sampling is included. And for the practical purposes, for all practical purposes, when we go for research, when we go for research, then we go for, in fact, we want to achieve more and more, in fact, a standard type of the sample. However, these complex random sampling, which are very popular in practical sense, they are, they include both the qualities of the random sampling and the non-random sampling, because the non-random sampling gives freedom to the researcher, whereas the random sampling maintains the strictness and controls the principles of equal opportunity or equal chance to the members in the strict sense. So, both of these are combined together, they are mixed together to arrive at the complex random sampling. So, I am sure I have been able to clear the various kind of complex random sampling techniques, and once the researcher goes to the field of research, when he starts the research, he is very clear in developing in his sample design, because the sample design is also to be developed before we go for research. So, the sample design, which one of these sample designs is best suited to the kind of problem that he or she is going to research upon again depends upon the logic of the research, because after all the researcher has to look into the nature of the problem that he or she is pursuing upon, and depending upon that, one has to develop sampling design based on these techniques. Thank you very much.